Hey College Algebra, this is section 2.5. We are going to be looking at equations of lines, so more linear functions. We're going to be looking at, again, something we've looked at in the previous section called point-slope form, slope-intercept form, and vertical-horizontal lines. We're also going to be looking more into the standard form of the linear equation. And then we're going to be looking at parallel and perpendicular lines. Okay, here's what we call point-slope form of the equation of a line. It's actually incorrect. We should have an equal sign right here instead of a minus sign. So what this point-slope form is you are given a point and you are given the slope, which is what m represents as we learned in the last section. And your point, xy, goes in for this x and this y, and your slope goes in for here, and you have an equation of your line. And if it asks you to put it in the slope-intercept form, just solve for y, and you've got it. Okay? So here it says, find an equation of the line through 3, -5, having the slope of -2. And we're going to be using the point-slope form. So here we go. This is what we're going to do. We're going to use our slope of -2 and our point 3, -5 and plug all of those things in. So -5 goes in for our y1 and our slope, -2 goes in for m, and then our x1 is the 3. And then at this point, unless I say leave it in this form right here, I do want you to solve for y and put it in the sloped-intercept form. Okay, so this is going to be y plus 5 equals, and now we're going to distribute the -2 across the parentheses and get that. And now to solve for y, just subtract by 5. And we have the equation y equals -2x, not minus 5. Sorry guys. Plus 1. Okay, so that is our equation that we're looking for, and we are done with this example anyway. Find an equation of the line through -4, 3. Here's another example of using the point-slope form. And 5, -1. Write the results in standard form. Okay, so it says first find the slope. This I've typed out the steps for you. So we're going to find the slope first. Well, remember in the last section, to find the slope, it was y2 minus y1 over x2 minus x1, and we plugged in our points that we were given into those x and y values. So here we're going to do 3 minus -1 over -4 minus 5, and that ends up giving us -4/9. So there's our slope, and now we're going to use the point-slope form to help us find our equation. Okay, so use the y minus y1 equals our slope times x minus x1. Plug in our, it doesn't matter which point you use at this stage in our solving for our equation. We can use the -4, 3 in for our x1, y1, or we can use the 5, -1. Don't try to use both. Just use one or the other. So I'm going to use -4, 3. And in for the m, it goes your slope Okay, now what we're going to do is put this in standard form. And how I'm going to show you to do that is in standard form, it looks something like this. AX plus BY equals C. So we're not solving for y, we're going to put it in this form here. First step I'm going to do is get rid of my fraction here, the negative 4/9, by multiplying both sides by the 9. Okay, so whenever I do that, I get this on this side of the equation, and this on that side of the equation. Now I'm going to multiply out my 9, distribute the 9, and then also the negative 4 on the other side. Sorry. And there we have that portion of it. Now we almost have it in this form right here. What I say is move the x value over, the negative 4x, over to the left side of the equation, and then move the 27 over to the other side of the equation, and you've got it in standard form. So I'm going to add 4x to both sides to get 4x, and then I'm going to leave my 9y. Then I'm going to subtract or add the 27 to both sides of the equation, which gives us a positive 11. And there it is. That is standard form. Okay, this is just an extension of example 2. It's asking us now to verify our equation using that 5, negative 1 is also a point on that line. So what we're going to do is just use our equation that we just got from the previous slide there, the 4x plus 9y equals 11, and verify that 5, negative 1 is a point on this line by plugging in our values for x and y. And then this right here, well, we get, let's see, 16 minus 9. No, 20 minus 9. Okay. Which is 11. So there we go. We verified our results that we do have a line containing both of these points up here. Okay? Okay, so this is just kind of a review. This right here is called slope-intercept form whenever it's in the form of y equals mx plus b. The reason it's called slope-intercept form is because you have your slope right here and you have your intercept. That's what b stands for, is your y-intercept. So this is where it crosses the y-axis, okay, or where x equals 0. Okay, this example, you're given an equation in standard form, and you're asked to find the slope and the y-intercept of the line with the equation given. So, what I'm going to tell you here is there's a couple of different ways we can go about this. We could solve for our y, and then it's in the slope-intercept form, and we have our slope and we've got our intercept. So that's a really good way to, if you're finding slope and the y-intercept, to do this one. And that's what I'm going to do. I will show you another way to find the slope from standard form here in just a little bit. So let's solve this equation for y by subtracting 3x. And then I'm going to divide both sides by the -4. So what I'm going to do is divide by -4 here, divide by -4 here. Instead of dividing everything by -4. Okay, so we can actually see what is our slope and what is our intercept. All right, -4 over -3 over -4 is right here. That gives us a positive 3 over 4 x. And then 12 over -4, that's going to give us a -3. Okay, so right here we have our slope right here and our intercept right here. Make sure you take the negative or your positive sign with it. So our slope is 3/4 and our y-intercept, or you can call it b, is -3. And we're done. Okay, another way to find the slope whenever you have your equation in standard form is just like this. Okay, so here is standard form, your ax plus by equals c. So another way to find slope is by saying negative a over b. And there's your slope. So whatever your coefficient is on your x and your y, put a negative sign in front of it, and you've got your slope. So see how that would match up with this equation right here? We have a and -4, so it will become a positive 3/4. Example 4, find an equation of a line through -2, 4 and 2, 2. Then graph the line using slope-intercept form. Alright, I'm going to solve for the slope, and then I'm going to use my point-slope form to find the equation in slope-intercept form. That's what I'm going to do. So, find your slope. So 4 minus 2 over -2 minus 2. That is going to give us -1/2. Now I'm going to use my point-slope form. The y minus y1 equals m times x minus x1. And use one of my 2 points to plug in my x1 and my y1. So let's just use 2, 2. Make sure you put in your slope, -1/2. And then at this point, solve for y, distribute the -1/2 across the parentheses. Let's see, plus 1. So whenever I solve for y, I add 2 to both sides. And I get this equation right here. There is my equation of my line in slope-intercept form. Now I'm going to graph this on the next page. Remember, your slope for this equation is -1/2, and then your y-intercept is 3. So always start with plotting your y-intercept first if you have it. So that was 3. I'm doing a different color. That, and the slope was -1/2. So, like I told you in the previous video, is whenever you have a negative slope, do the fall and then run to the right. So we're going to fall 1 and then run to the right 2. There you go. There's another point on your line, And you can graph that. And you are done. Here in example 5, we're going to apply what we know about slopes, y-intercepts, and x-intercepts to help us write the equation of a function. So here's what I'm going to start out with. I'm going to just start out with finding the x and the y-intercepts, and then we're going to find the slope from that. All right, so your y-intercept is where it crosses the y-axis, so here at this point, 5, 0, 5, we're at y equals 5. And then your x-intercept is here where it crosses the x-axis at x equals -2. Now that we have our y-intercept and our x-intercept, those are actually 2 points that we can use to help us find the slope. Because this point right here, our y-intercept, is known as 0, 5. Sorry, there we go. It's a parentheses, not a bracket. And then our x-intercept is known as -2, 0. We can use that in easily finding our slope. So m equals, 5 over -2, just not plugging in the zeros. So our our slope here is 5 over 2. Okay. Now that we have our slope, we have our y-intercept, we can come up with our equation of our function pretty easily, because that's all we really need to have is our slope and our intercept to write it in slope-intercept form, in this form right here, y equals mx plus b. So our m is our 5 over 2, our b is our y-intercept, 5, and we are done. Here we learn about parallel lines. If you'll remember from geometry or from maybe another previous class, parallel lines, they will never intersect each other. They, here in this case, for equations of lines, they have the same slope. And that's how we're going to apply it in this section here, is we're going to come up with an equation of a line that is parallel to another line. And having the same slope, it will come into play there. And then same goes with perpendicular. Perpendicular lines, whenever we say one line is perpendicular to another line, their slopes have a product of -1. Or you can say that the slope of one line is the negative reciprocal of the other slope of the other line. So negative reciprocal means something like this. Say I have a slope of 1/2. The negative reciprocal of that, reciprocal means I'm going to switch my numerator and denominator. And then negative, I'm just going to put a negative on it. And that ends up being -2. So these two slopes that I have right here, 1/2 and -2, those are perpendicular slopes to each other. And that's how you would find a slope that's perpendicular to another line, is by taking the negative reciprocal. All right, and kind of a review here. What we have is, here's an equation right here. Y equals mx plus b, that's just slope-intercept form. And then here we have point-slope form, where we have a given point and we can figure out our slope and then find our equation from that. And this one is a bit trickier sometimes, the standard form of an equation of a line. But here are some helpful tips about if you have an equation of a line, how to find the slope, the y-intercept, and x-intercepts. The slope of an equation in this form, ax plus by equals c, is found just like this, as I found earlier in an exercise, negative a over b. And then also the x-intercept, you can find it by saying your value of c over a. And your y-intercept, c over b. So those are some quick ways of finding the slopes and x and y-intercepts of your equation of a line in standard form. And then from the previous section, here's a review. A horizontal line has a slope of 0 and is located at the y-intercept, b. And then a vertical line is going to be the equation x equals then some constant number, and it has an undefined slope. Okay. Alright, what I have left over here are two more examples. One that has to do with parallel lines, and the other one has to do with perpendicular lines. So pay close attention. This is definitely going to be tested over. Whenever we have an equation, we're trying to find an equation of a line, and then this is telling us in slope-intercept form, that passes through this point and is parallel to this line right here. What we want to do with this information, this equation that we're given, is take the slope from that, and that's all we need. Parallel lines are going to have the same slope, so to get the slope for the new equation, we need to find the slope of the other equation. And if you remember from a previous slide, our slope is equal to negative a over b. So negative 3 over negative 2, which is 3 over 2. And now to find the equation of the line in slope-intercept form, you have a point, you have a slope, use the point-slope form. Y minus y1 equals m times x minus x1. And plug in everything that you have. You have a y value of negative 4, so it's going to be y plus 4. And your slope is 3/2. And your x value is 2. Multiply out the 3/2, subtract by 4. And let's see what we get. 3/2 x minus 3. So y equals, if you subtract 4 from both sides, 3/2 x minus 7. And there you have it. There is the equation of the line that is parallel to the one given here, but goes through this point right here given. Alright, we're done. Now, similar process here, except what this one is, it says we have a line that is, we're going to have a line that is perpendicular to this equation. Okay? And same point that we're using from the previous exercise. Okay, we have, again, to take the slope from this given equation, which we found was m equals 3 over 2. Remember, for perpendicular lines, we need to have the negative reciprocal of our given slope. So we are given the slope 3/2, but the negative reciprocal that we're going to use to create our new line going through 2, -4 is m equals -2/3. Okay, so just a little bit of information. If our slope was already negative, say it was -3/2, then the negative reciprocal would be a positive 2/3. Okay, but we have a positive 3/2, so negative reciprocal is -2/3. And then again, we're going to use the point slope form and plug in everything we know to find our equation of our line that is perpendicular to the one we're given. So y minus, or minus 4, so plus 4 equals -2/3 over, or times x minus 2. Alright, so distribute the -2/3, and we get -2/3 x plus 4/3. And now subtract a 4 from both sides, and we get minus 8/3. And that is our equation in slope-intercept form that we are looking for. So this line that I just circled is perpendicular to this one in this rectangle here, because of how we went throughout the steps. Okay, I think, yep, that is it for this video. I will see you all in class. Bye.